Hello everyone, myself Prayak Patel, working as Assistant Professor in IT ICT Department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss the next unit, unit number 3, optimization and matching. Now in unit number 3, first we discuss the first topic as a transport network. Now in transport network, what is the transport network? Transport network means you want to flow something like liquid. For example, oil or water, you want to flow in the network. So for example, this first is considered as a pump. From the pump, you want to transfer the water up to your last point at the destination. Now here multiple path is available between these two components, source and destination. So how we can transfer the water, how we can flow the water? So it is considered as a transport network. So in transport network, we can say that what is the maximum flow of this network, what is the mini cut of this network, like this. So we will discuss all the component of the transport network in this unit. Now first, here we consider the one pipeline. In this pipeline, we have a two part. First part as A, second part as a B. Now what is the difference between these two parts? So here in part A, capacity of the part A is a 20 liter per minute. So part A of this figure transfer the water or liquid up to the 20 liters per minute. Now second part of this network is part B. Now in part B, capacity is equal to 40 liter per minute. So direction of this flow is like this from A to B. So this is a direction or flow of the direction. So what is the maximum capacity of this network? What is the maximum capacity of this circuit? So here we can say that the minimum flow in this network is a 20 liter for A and 40 liter for B. So minimum out of these two is considered as a 20 liter. So 20 liter transfer in this flow using this circuit. Now second figure is this type of figure. In this figure, flow direction from A to B, but capacity of A and B is changed. So capacity of A is 25 liter per minute, capacity of part B as a 10 liter per minute, and direction is from A to B. Now what is the maximum flow of this network? What is the maximum capacity of this network? So here actually first capacity is 20 liter per minute, second capacity is 10 liter per minute. That means minimum out of these two is a 10 liter per minute, because here in part as a 25 liter but out part as a 10 liter. So basically we can say that the overall capacity of this network is a 10 liter per minute. So this is a transport network. Now understand how we can represent the transport network in form of graph, because basically your source node and destination node is available in your previous figure. So represent this network in form of directed graph. Oil that flow through pipelines, such situations we interpret the weight of an edge in the directed graph as a capacity that place an upper limit on this figure. So here in this example we write for each edge we write the some number. So that number represent the capacity of this line, capacity of this pipe. So here we can consider first node as a source, last node as a destination node, that means the sink, and remaining intermediate node as a B and C. For each and every edge we represent the direction as well as weight of this each and every edge. For example, the amount of oil that can flow through a certain part of a system of pipelines is represented in this figure. Now here see the definition of the transport network. So basically definition of the transport network is let N equal to VE. So here N is a network. So network contain V and E, node of set of nodes and set of edges. So N equal to VE. Be a loop free connected directed graph. So here directed graph is given. Then N is called a network or transport network if the following conditions are satisfied. So this figure is called the transport network or network if they satisfy this first condition as there exists a unique vertex A belongs to V with ID A. IDA means in degree of A. The in degree of A equal to 0. This vertex A is called the source vertex. Now here in this figure, node A considered as a source node, source vertex, because no any incoming edge available for the node A. All the nodes or all the edges available for the node A as a outgoing edges. So in degree equal to 0. So in degree equal to 0, that means this node is a source node. Now second definition is a sink. Sink means your destination node. So for the destination node, we can say that the out degree of this particular node equal to 0. So there is a unique vertex Z belongs to V called the sink, where out degree of Z equal to 0. So here in this case, in degree of Z is available, but out degree of Z equal to 0. So Z consider as a your node as a sink node. Now remaining all the node is considered as an intermediate node, because this node is not in degree 0 or out degree 0. So if in degree 0, then source, out degree 0, then destination or sink. Now third part. The graph n is weighted. So there is a function from E to set of non-negative integers that assign to each edge E equal to VW belongs to E. So VW belongs to E, set of edges. A capacity denoted by C of E equal to C of VW. That means E considered as a one edge. For example, B2D as a edge. So V2W as a edge or B2D as a edge. So capacity of this edge is represented by C of E, because E as a edge. So C of E as a capacity of network, or C of VW is also considered as a capacity. Here we represent the E as a edge, or we represent the edge as a VW. So this is a capacity of the network. Now after that, in transport network, in this figure, A considered as a your source node. Now what is the sink? Sink means node number Z considered as a sink node. Now capacities are shown behind the each edge. So here we can say that the from A to B value is 5. That means capacity of the edge A to B equal to 5. They maximum transfer the water or any liquid as a maximum 5 liter per minute. Now see here, C of AB plus C of AG equal to 5 plus 7. So here from the source node we have a two option. First option is A to B and second option is A to G. So addition of these two consider as a 12. The amount of the water transfer from A to your destination node is maximum 12, not greater than 12. Now consider the another scenario for the sink. We already see that from the source maximum water transfer as a 12 liter. But for the destination or for the sink, we calculate this thing. So incoming is for the Z equal to C, D to Z and H to Z. So C of dz plus C of hz equal to 5 plus 6 equal to 11. That means here value is 11 and previous value is 12. So minimum out of this 2 is considered as a 12, because the amount is further restricted, not greater than the 11. So maximum water transfer from source to destination, from A to Z, from source to G, we can say that the 11, not greater than the 11. Now next definition is a flow. Now what is the flow? If n equal to VE is a transport network, a function f from E to the non-negative integer is called a flow for the n, if they satisfy the condition. First is f of E less or equal to C of E. For each edge E belongs to E. So here we can say that the for any edge E, flow of the network is less or equal to capacity of the network. So for example, for the any edge we can say that the E as a edge, then flow means F and capacity means C. So F of E less or equal to C of E means flow of the your edge is less or equal to capacity of your edge. This is always satisfied. Then second thing, for each V belongs to V other than the source A or sink Z, sigma W belongs to V F of WV equal to sigma W belongs to V F of VW If there is no edge VW, then we can say that the f of VW equal to 0. Now here V as a vertex node. Now without the source and destination, means here we not consider the node A and node Z. Remaining all the node like B, D, G and tangent, we can apply this formula. So here incoming flow of the particular node and outgoing flow for the particular node is equal to same. That means incoming ACs or incoming weight for the node B, incoming flow for the node B is equal to outgoing from the B. Both are equal. So the amount of materials following into the vertex A must equal to the amount that flows out from this vertex. So flowing in is equal to flowing out. This is called the flow. This is so for all vertex except the source and sink. So for sink and source this is not satisfied. For remaining all vertex we satisfy this thing. Incoming total flow is equal to outgoing total flow. Now see here in this figure we see the what is the flow or what is the capacity. So in this figure we write the two things for each and every edge. For example, for edge A to G we write here two numbers. One is 7, second one is 5. Now what is the meaning of 7? What is the meaning of 5? So here we represent the capacity and flow. Now 7, first value consider as a capacity of the edge E. So C of E consider as a 7. Now what is the second value? Second value is 5 and 5 represent the flow of this particular edge E. So flow FE equal to 5. So 7 as a capacity, 5 as a flow. Now for the edge A to B also we represent the same thing, 5 as a capacity, 3 as a flow. So for each and every edge we represent these two values. Now this two value is represented in form of X and Y, pair of X and Y. So X equal to C of E, X equal to capacity and Y equal to flow. So Y equal to F of E. The label on each edge E satisfy the F of E less or equal to C of E. So see here, flow is always less or equal to capacity. So 7 is a capacity, 5 is a flow. So 5 is less than 7, 3 is less than 5, 4 is less than 2 is less than 4, 3 is less than 6, 2 is less than 5, 3 is less than 5, 4 is less than 6, 2 is less or equal to 2 and 4 is less than 5. So here we can say that this all the conditions satisfy for this figure. Now second condition is for each V belongs to V, for each node without source and sink, sigma W belongs to V, F WV equal to sigma W belongs to V, F V to W. That means incoming edges for the V and outgoing edges from V both are equal. So see here in this figure, for the node H, for the vertex H, we calculate this thing. So for the vertex H, F of WH, that means incoming edges of the node F, incoming flow of the node H. So here incoming flow for the node H equal to F of WH. So here two edges as a incoming for the node H, G to H and B to H. So value of these two is 3 plus 3 because second part has a flow. So 3 plus 3 equal to 6. Now for the outgoing, flow out from the vertex S is a F of HW. So here H to any node, H to W means any node. So H to D and H to Z, 2 are possible. So here first value H to D flow as a 2, H to Z flow as a 4. So 2 plus 4 equal to 6. That means for the node H, incoming flow is equal to outgoing flow. So this is called the flow. Now after that, next definition is a saturated and unsaturated flow. Now let F be a flow for a transport network N equal to VE and as E of the network is called the saturated if F of E equal to C of E. That means flow is equal to capacity. If flow of your is equal to capacity of your is, then it is called the saturated. Or another case is considered as a unsaturated. When F of E less than C of E, the is called the unsaturated. So here see in this figure is H to D is considered as a 2 as a capacity and 2 as a flow. So H to D considered as a saturated flow. Now for remaining all the ages we can say that the unsaturated, because no any flow and capacity are equal for the remaining any age. So this remaining all age is considered as a unsaturated flow. Now after that, next definition is a value of the flow. So let F be a flow for a transport network N equal to VE if A is the source of your network N. Then value of the F, value of the flow represented using the val F equal to sigma V belongs to V F of AB. Here consider the A as a source node. So value of the flow is considered as an outgoing value from the node A, from the source node A. It is called the value of the flow. So for example, here consider the value of F equal to sigma V belongs to V F of AB, because here A as a source node. So A to any node is considered as a AB. So here A to B and A to G, two paths is possible. So F of AB plus F of AG equal to 3 plus 5 equal to 8, because here we consider the value of flow, not as a capacity. So total equal to 8. Now see here for the next value, the determination of the maximum flow. A flow that achieves the greatest possible value. To accomplish this, we observe that in the network in this figure, sigma V belongs to V F of AB equal to F of AB plus F of AG. So we already see 3 plus 5 equal to 8. Now this is the outgoing value from the source node. Now check for the incoming value for the destination, means for the sink. So for the node Z, what is the incoming value of the flow? So one is a D to Z, second one is a H to Z. D to Z value equal to 4, H to Z value equal to 4. So 4 plus 4 equal to F of DZ plus F of HZ equal to sigma V belongs to V F of VZ. So this is a representation of value of the flow. So here your outgoing flow from the source and incoming flow for the destination both are equal. The total flow leaving the source is equal to the total flow into the sink Z. So this is called the value of the network. Now next is a cut. So here definition of the cut is, if N equal to VE is a transport network and C is a cut set of the undirected graph associated with the network N, then C is called a cut or an AZ cut if the removal of the edges in C from the network result in a separation of the A and Z. That means in this network, if we remove some edges from this network and this removal of the particular edges divide this graph, this network into two parts. But in this two part, first part contain the node as a as a source node, and second part contain the node as a Z as your sink node. So if we divide the source and sink in two parts, then this is considered as a cut of the network. So see here, this red line represent the cut. So for this cut, we cut the three edges B to D, B to H and G to H. If we remove these three edges, then this network divided into two parts. And these two parts containing the different elements. Now here see in this figure, we represent the two different cut. First cut as a C1, second cut as a C2. Each of the dotted curve in figure indicate a cut for a given network. Let C1 consider here C1 cut. So C1 cut is considered as a removing the edge A to G, B to D, B to G and B to H. If we remove these four edges, then this network divided into two parts using the only cut C1. Now in this part we can divide the network into two parts. Then what is the two part? First part as a and B. So node A and B consider as a P set P and another set as a P dash. So P dash containing the remaining four element as a G, D, H and Z. So C1 is denoted by P dash or P bar. So this is considered as a cut C represented by P dash. Now in this cut we represent the cut C P dash Then what is the capacity of this cut? We already know what is the cut. In here cut C1, we represent the two part. One part as a PAB, another part as a P dash or P bar, D, H, G and Z. Now what is the capacity of this cut? So capacity of this cut represented by C of PP or C of PP dash or P bar. So C of P bar is considered as a capacity of cut. Equation of this capacity of cut equal to sigma V belongs to P, W belongs to P dash, C VW. So capacity of VW. Now the sum of the capacity of the A's is VW, where V belongs to P and W belongs to P dash. So remember that for removing these three A's or removing for any A's, if we consider the first element from the first set P and another element from the another set P dash. So see here in this example, C of capacity of P dash equal to C of AG plus C of BD plus C of BH. Here we write only three A's because one A's is a G to B. So G to B is direction from G to B. That means here G find from the second set P dash and B find in first set P. So this is not possible. Your first element compulsorily occurs from the first set P and second element compulsorily available in the second set P dash. So this is not satisfied. So here we write only three A's. Now value of these three A's is as a 7 plus 4 plus 6. So total of this is equal to 17. So capacity of this cut C1 is equal to 17. Now see the another cut in this figure, another cut as a cut C2. Now for the cut C2 we divide the network into two parts. Here in cut C2 we cut the A's B to D, then B to H and G to H. So if we remove these three A's, then our network is divided into two parts. First part as a Q and second part as a Q dash. So Q as a B and G and second part Q dash equal to D, H and Z. So in this network also we calculate the capacity of this cut. So capacity of this cut C2 equal to CQ dash equal to CBD plus CBH plus CGH. So capacity of these three A's is equal to 4 plus 6 plus 5, total equal to 15. So if we remove these A's, then we divide the network into two parts and capacity of this cut equal to 15. So here we discuss about the what is the capacity of network and what is the cut, what is the network or what is the transport network in today's lecture. Thank you for watching this video.